Good morning, everyone. Now here we have a heatsink thermal. Now it monitors the temperature of the heatsink. It sits right beside the IGBT power module in a Magnetek model GPD505V-B001. Now this one is good, but I want to show you how you can test this device for serviceability, just in case you ever have to. Now, I got two resistors right here. They're not part of the test, but they're going to allow me to clip my probes onto the connector of the thermal wiring harness. I'm going to set them down in the socket pins, and that will allow me to clip onto that connector. Spread those out a little bit. Grab my clip leads. Now the polarity does not matter, so you can connect them any way you want. Set our meter to ohms mode. And right now, at room temperature, well, it's kind of chilly in here. We're in November now, ain't we? When I got to turn the heat on. We have 25.3 kilo ohms. Now it's going to get noisy in here because I'm going to use this heat gun to heat up that thermal. Now, this thermal device, the resistance will go down as we apply more heat. Here we go. Look at that resistance go down as the thermal heats up. Let's see how far we can take it. I'm going to back up a little bit. I don't want to melt that wiring harness. Now we're near 200 ohms. We just passed 200 ohms. Looks like we've about stopped at the lowest measurement. 159, 158. 151.8. I got a little bit closer. We're still going towards zero. Well, it looks like we could take this all the way down to 0 ohms. $73. Get a little bit closer. Yep. That's it. We bottomed out at 73 ohms. Now let's let the thermal come back up to room temperature. We'll watch the resistance rise back up to 25 kilo ohms. This thermal right here sits beside the IGBT power module that runs the motor, and the drive can monitor that temperature of the IGBT that's dissipated into the heatsink. And if the temperature starts to get very hot, the resistance will fall like we saw when we heated it up with the heat gun here. And at some point, the drive will say, oh, we're too hot, we need to shut down. And it'll stop driving that motor via the IGBT power line. It will turn the gate firing voltages off and let that motor and IGBT cool off. Isn't that fascinating? How you can monitor the outside world with devices such as this. What's our resistance reading now? 2.2K, 2.3K. It's going up pretty good. It's going up pretty fast. Still take a while to get there. I'm going to put a cooling fan in front of that thermal and turn it on. We'll see how fast that resistance rises. Take it up a little bit faster when we blow that heat away from that thermal. We're at 12K, 13K, almost there. 10 more K to go. Now there are some thermals that are opposite of this case. They start out at 0 to near 0 ohms, and as you apply heat, the resistance goes up instead of down like this one did. So don't be surprised if you ever find one like that. Still increasing, but very slowly now. I used to have a can of freeze spray to troubleshoot overheating problems in electronics. But I emptied that can out a long time ago. I don't have it anymore. If I had it, I'd spray me some freeze spray on that device right there. Alright everyone, I hope you enjoyed that video of how to test a thermal device, a Heatsink thermal from a Magnetek inverter drive. That was a lot of fun. That's fascinating stuff right there. That is fascinating. Y'all have a good day. We're not doing too bad here. And we'll see you next time.